Good morning, students. In the previous class, that is class 1 of the chapter group 17 halogen family, I already completed introduction part, nomenclature, general trends in physical property, general trends in chemical property, and anomalous behavior, that is abnormal behavior of fluorine. Why fluorine behaves differently, and what are the different behaviors of fluorine? Today, that is in class 2 of the chapter group 17, I will try to complete the compounds of halogen. Two compounds are there in our syllabus. One is chlorine, one is hydrogen chloride. So I will try to complete today the method of preparation, property and uses of chlorine, method of preparation, property, uses of hydrogen chloride, last interhalogen compound and oxoacid. So let us start first one, that is method of preparation of chlorine. First today we discuss methods of preparation of chlorine. Under this one, first is the laboratory method. First one is laboratory method of preparation. That means chlorine is prepared in the laboratory by reacting with concentrated hydrochloric acid with powder potassium permanganate. I repeat again, chlorine is prepared in the laboratory by heating concentrated hydrochloric acid with powder potassium permanganate. The equation is potassium permanganate plus hydrochloric acid give rise to potassium chloride, manganese chloride plus water plus chlorine. I repeat again, when potassium permanganate treated with chlorine, concentrated chlorine give rise to potassium chloride, manganese chloride, water and chlorine. It is the first laboratory method of preparation of chlorine. Chlorine also may be prepared in the laboratory by reacting with concentrated sulfuric acid with sodium chloride in presence of manganese dioxide. I repeat again, chlorine may also be prepared in the laboratory by reacting with concentrated sulfuric acid with sodium chloride in presence of manganese dioxide. The reaction is, second method is, that is sodium chloride, manganese dioxide plus concentrated sulfuric acid. When sodium chloride reacts with the manganese dioxide with concentrated sulfuric acid, product is sodium bisulfate plus manganese sulfate plus water plus chlorine. Sodium bisulfate plus manganese sulfate plus water plus chlorine. It is the laboratory method of preparation. It is prepared by reacting HCl with potassium permanganate and also by reacting sulfuric acid in sodium chloride in presence of manganese dioxide. Next we go to the second method, that by the oxidation of hydrochloric acid. Move to the second method, that is oxidation of, second method, by oxidation of HCl. That means heating concentrated sulfuric acid, heating concentrated hydrochloric acid with oxidizing agent. Common oxidizing agents are manganese dioxide, KMnO4, K2Cr2O7, lead dioxide, red lead, etc. These are known as common oxidizing agent. So by heating concentrated hydrochloric acid with such type of oxidizing agent give rise to chlorine. So the common reactions are that first one is manganese dioxide reacts with hydrogen chloride. That is when manganese dioxide, that means when manganese dioxide reacts with hydrochloric acid, resulting in the formation of manganese chloride plus water, resulting in the formation of manganese chloride plus water plus chlorine. Similarly, when potassium permanganate treated with hydrogen chloride give rise to potassium chloride, magnesium chloride, water plus chlorine. I repeat again. When potassium permanganate treated with chlorine give rise to potassium chloride, manganese chloride, water plus chlorine. Next one is the first one, second one, third one. That is potassium dichromate. K2Cr2O7 treated with hydrogen chloride give rise to potassium chloride, chromium chloride, water plus chlorine. I repeat again. When potassium dichromate treated with hydrogen chloride give rise to potassium chloride, chromium chloride, water and chlorine. Next one is lead dioxide. When lead dioxide treated with hydrogen chloride resulting in the formation of lead chloride plus water plus chlorine. Similarly, when red lead Pb3O4 treated with hydrogen chloride, when red lead treated with hydrogen chloride resulting in the formation of lead chloride, water and chlorine, that is PbCl2 H2O plus Cl2. These are the common methods of preparation of chlorine. Next we switch over to the chemical property. The first chemical property is action with metal, non-metal and metalloid. Next switch over to chemical property. Next, chemical properties. Under this heading, first one is action with metals, non-metals and metalloids. First chemical property, action with metal, non-metal and metalloids. That means chlorine reacts with metal, non-metal and metalloid, resulting in the formation of corresponding metal chloride. For example, when sodium reacts with chlorine resulting in the formation of sodium chloride, aluminium when reacts with chlorine resulting in the formation of aluminium chloride, when sodium reacts with chlorine forms sodium chloride, aluminum reacts with chlorine to form aluminum chloride, when phosphorus reacts with chlorine to form phosphorus trichloride, when phosphorus reacts with chlorine to form phosphorus trichloride, when arsenic reacts with chlorine to form arsenic chloride, arsenic reacts with chlorine to form arsenic chloride. That is, these are some reactions of action with metal, non-metal and metalloid. Next is oxidizing nature. Second we go through the oxidizing property. Second chemical property, that is oxidizing property. Point 2, oxidizing properties. The second chemical property is oxidizing property. That means in presence of moisture, chlorine behaves as an oxidizing agent. I repeat again. In presence of moisture, chlorine behaves as an oxidizing agent. For example, it oxidizes acidified ferrous sulfate to ferric sulfate. For example, it oxidizes acidified ferrous sulfate FeSO4 plus H2SO4 plus chlorine give rise to Fe2SO4 whole thrice plus Hscl. I repeat again. It oxidizes acidified ferrous sulfate to ferric sulfate. Next property is, next example is, it oxidizes sulfur dioxide to sulfuric acid. Next is, it oxidizes sulfur dioxide to sulfuric acid. I repeat again. It oxidizes sulfur dioxide to sulfuric acid. It oxidizes hydrogen sulfide to sulfur. Next is, in presence of water, it oxidizes in presence of water, it oxidizes hydrogen sulfide to sulfur. The expected equation is hydrogen sulfide plus chlorine give rise to hydrogen chloride plus sulfur. These are the common example under the oxidizing property. Next, we discuss about action with ammonia. Next chemical property, third chemical property, action with ammonia. The very important one for mark point of view. Third chemical property, that is action with ammonia. Under this heading, two reaction is there. One is excess ammonia reacts with chlorine. One is ammonia reacts with excess chlorine. I repeat again. When excess ammonia reacts with chlorine, resulting the formation of ammonium chloride with the evaporation of nitrogen gas. On the other hand, when excess chlorine reacts with ammonia, resulting the formation of nitrogen trichloride, that is the explosive. Mark that. Two equations is there. One is ammonia reacts with chlorine. It is excess is ammonia to form N2 plus NH4Cl. Ammonium chloride is formed with the evaporation of nitrogen gas. On the other hand, when ammonia reacts with excess chlorine, then resulting the formation of an explosive, that is nitrogen trichloride. It is used as an explosive plus 3Hcl. I repeat again, very important. Question is, what happens when excess ammonia reacts with chlorine? What happens when chlorine reacts with insufficient amount of ammonia, or ammonia reacts with excess amount of chlorine? Next chemical property, that is bleaching property of chlorine. Next chemical property, the bleaching nature or bleaching action. Bleaching action of chlorine. Mark that. In presence of moisture, when chlorine combines with moisture, liberating nascent oxygen, which play an important role to act as a bleaching agent. Mark that. Chlorine plus water give rise to Hscl plus nascent. This nascent oxygen play an important role for acting the bleaching action. And bleaching action of chlorine is due to its oxidizing nature and it is permanent. Very important one, that is bleaching action of chlorine is due to its oxidizing nature and it is permanent. That means, for example, vegetable coloring matter plus nascent oxygen give rise to vegetable colorless matter. I repeat again. The bleaching action of chlorine in presence of moisture is due to the oxidizing nature and it is permanent. Next one is action with alkali. The very important for this chapter, that is action with alkali. Next chemical property. Next chemical property, that is action with alkali. Under this heading also two important reaction is there. That is action with the cold dilute alkali and action with the hot concentrated alkali. I repeat again. When the chlorine reacts with cold dilute alkali, resulting the formation of corresponding metal chloride and metal hypochlorite. On the other hand, when chlorine reacts with hot concentrated alkali, resulting the formation of metal chloride and metal chlorate. Mark the reaction. Which one is? Chlorine reacts with dilute in presence of cold, resulting in the formation of corresponding metal chloride and metal hypochlorite, that is known as sodium hypochlorite. Sodium hypochlorite plus H2. Similarly, if we reacts with chlorine, reacts with calcium hydroxide, that is a dilute in cold, resulting in the formation of calcium chloride plus calcium hypochlorite plus water. Mark that. In presence of cold dilute alkali, they form corresponding metal chloride and metal hypochlorite. On the other hand, next one is chlorine reacts with concentrated alkali in hot, resulting in the formation of metal chloride plus metal chlorate, that is its name is sodium chlorate. Similarly, chlorine reacts with calcium hydroxide concentrated in hot, resulting in the formation of calcium chloride plus calcium chlorate plus water. Very important one for mark point of view. If it is a dilute alkali, it is for corresponding metal chloride plus metal hypochlorite. On the other hand, if it is a hot concentrated alkali, resulting in the formation of corresponding metal chloride and metal chlorate. It is all about the chemical property. Next, switch over to uses. Uses of chlorine. Next, uses of chlorine. 2 to 3 points are there. It is used as a bleaching agent. It is used in sterilizing drinking water. It is used in industry for manufacture of dyes. It is used for the preparation of glucose. These are some common example uses of chlorine. The most important thing is that used as a bleaching agent and used sterilizing drinking water. Next, switch over to the second compound of halogen, that is method of preparation of hydrogen chloride or hydrochloric acid. Next, move to the second compound, that is method of preparation of HCl. Move to laboratory method. It is prepared in the laboratory. It is prepared in the laboratory by heating concentrated sulfuric acid with sodium chloride. Mark the reactions. That is sodium chloride plus H2SO4 at 420 Kelvin to form sodium hydrogen sulfate plus HCl. Again, sodium chloride reacts with sodium hydrogen sulfate. Sodium hydrogen sulfate at 823 Kelvin, resulting the formation of sodium sulfate plus Hscl. Mark that. It is a laboratory method of evaporation. This hydrogen chloride gas is collected by the upward displacement of air, and this gas is dried by passing through concentrated sulfuric acid. Though other drying agents are there, that is quicklime, calcium oxide, phosphorus pentoxide, P2O5, though they are commonly used as a drying agent, but these are not used for drying Hscl gas because it reacts with them. The question is that though quicklime and phosphorus pentoxide are well-known drying agent, yet it is not used for drying Hscl gas. Answer: because it reacts with them. It is a laboratory method. Next, switch over to the chemical property. Next, switch over to the chemical property of hydrochloric acid. Chemical property. We know that hydrochloric acid behaves as an acid. So first one is acidic nature. First chemical property, that is acidic nature. As it is acid, it reacts with metals liberating hydrogen. It reacts with metals like zinc, iron, magnesium to form corresponding metal chloride with the evolution of hydrogen gas. Mark that. Zinc plus hydrogen chloride give rise to zinc chloride plus H2. Magnesium plus hydrogen chloride give rise to magnesium chloride plus H2. Iron reacts with hydrogen chloride to form ferrous chloride plus liberation of hydrogen gas. As it is acid, it reacts with the bases like metal oxide, metal hydroxide, metal carbonate and metal bicarbonate, resulting in the formation of corresponding metal chloride. Mark that. Under the heading of acidic nature, as it is acid, reacts with the bases like metal oxide, metal hydroxide, metal hydroxide, metal carbonate and metal bicarbonate, resulting in the formation of corresponding metal chloride. I repeat again, as these are the acid, it reacts with the bases like metal oxide, hydroxide, carbonate and bicarbonate, resulting in the formation of corresponding metal chloride with the evolution of different gases. Let us discuss one by one. That means metal oxide, calcium oxide reacts with hydrogen chloride to form calcium chloride plus water. Sodium hydroxide reacts with hydrogen chloride to form sodium chloride plus water. Oxide part over, hydroxide part over. Next we go to carbonate. That is sodium carbonate reacts with hydrogen chloride to form sodium chloride plus water plus carbon dioxide. That is sodium bicarbonate reacts with hydrogen chloride, resulting in the formation of sodium chloride plus water plus carbon dioxide. These are the equations clear that the hydrogen chloride or hydrochloric acid behaves as an acid. Next, reaction, precipitation reaction. Next chemical property is precipitation reaction. Switch over to second chemical property, that is precipitation reaction. Second one is precipitation reaction. That means hydrogen chloride reacts with a soluble salt to form insoluble metal chloride. I repeat again. HCl react with the soluble salt of, that is the silver or lead, to form corresponding insoluble metal chloride. For example, silver nitrate reacts with Hscl to form silver chloride. It is white precipitate plus silver chloride plus HNO3. Similarly, another example, lead nitrate PbNO3 whole twice reacts with hydrogen chloride to form lead chloride. It is white precipitate lead chloride plus HNO3. These are some examples of precipitation reaction. Next, switch over to formation of aqua regia. The third chemical property is formation of aqua regia. It is the most important one, that is the formation of aqua regia. What is aqua regia? That means when concentrated hydrogen chloride treated with concentrated nitric acid. What is aqua regia? The mixture of concentrated HCl and concentrated HNO3 in the ratio of 3:1 give rise to a solution that is known as aqua regia. It is an important chemical which is used to dissolve noble metal like gold and silver, platinum. Mark the equation. I repeat again. Concentrated HCl, that is third chemical property, is formation of aqua regia. Formation of aqua regia. What is aqua regia? That is concentrated HCl 3 parts, concentrated HCl 3 parts, and concentrated HNO3 1 parts. When 3 parts of concentrated HCl combine with 1 parts of concentrated HNO3, resulting the formation of NaOCl plus NaOCl, that is nitrosyl chloride plus H2O plus nascent chlorine. This nascent chlorine plays an important role. That is, for example, gold plus nascent chlorine give rise to AuCl3. Its name is gold 3 chloride or auric chloride. Similarly, Pt plus 4Cl, that is PtCl4, that is platinum 4 chloride or platini chloride. I repeat again. The mixture of 3 parts of concentrated HCl and 1 parts of concentrated HNO3 is known as aqua regia, which are important chemicals used to dissolve noble metal like gold and platinum. Next we discuss the another chemical property, that is interhalogen compound. Let us discuss another one is interhalogen compound. Next we discuss interhalogen compounds. What do you mean by interhalogen compound? Very important one. It may be 2 marks or 3 marks. That is, these are the binary diamagnetic compound. I repeat again. Interhalogen compound is defined as the binary diamagnetic compound made by direct combination of halogen. Binary diamagnetic compound made by direct combination of halogen, and which is represented as X dash N. Mark that. It is the binary diamagnetic compound made by direct combination of two halogen, which is represented by X dash N, where X is the halogen having lower electronegativity, and X dash is the halogen having higher electronegativity, and N may be 1, 3, 5 and 7. I repeat again. These are binary diamagnetic compound made by direct combination of halogen, which is represented by the formula X dash N, where X is the halogen having lower electronegativity and X dash is the halogen having higher electronegativity, and N is either 1, 3, 5 and 7. Till now, 11 interhalogen compounds are discovered. Mark that. We represent them in the form of a table. That is X dash 1, X dash 3, X dash 5, X dash 7. It is the structure. Then it is the formula, then geometry. It is the linear, it is a T-shape, it is a square, pyramid, and it is a pentagonal, bipyramidal. I repeat again. That is, geometry of X dash 1 is linear, that of X dash 3 is a T-shape, X dash 5 is a square pyramid, and X dash 7 is a pentagonal bipyramidal. Some examples are there. That is Hscl, linear one, where n is equal to 1, here n is equal to 1, ClF, BrF, IF, IBr, BrCl, ICl. It is the unstable one. Similarly, ClF3, BrF3, IF3, it is unstable one. ICl3. Then BrF5, IF5, IF7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are some common examples of interhalogen compound. Next, switch over to oxoacids of halogen. Next is oxoacids of halogen. Next we discuss oxoacid of halogen. That is due to higher electronegativity. Due to higher electronegativity and small in size, chlorine form only one oxoacid. I repeat again. Due to smaller in size and higher electronegativity, chlorine form only one oxoacid, while other halogen, due to larger in size and lower electronegativity, it form different type of oxoacid. Mark that. We discuss one by one in the form of table. That is chlorine, it is chlorine, it is bromine, it is iodine, it is NEM, it is hypohalous acid, next is halous acid, next is halic acid, next is perhalic acid. Four type of oxo acids are there, depending upon the oxidation state. 1 + 1 + 3 + 5 + 7. Hypohalous acid, chlorine form HOF only 1, HOCl, HOBr, HOI. Chlorine due to smaller in size and higher electronegativity, it form only one oxo acid, while in other cases, that is HClO2, HClO3, HClO4, that is HBrO3, HBrO4, HiO3, HiO4. Mark that. This is known as hypohalous acid, hypofluorous acid, hypochlorous acid, hypobromous acid, hypoiodous acid. It is a halous acid, chlorous acid. It is a halic acid, that is chloric acid, bromic acid, iodic acid. It is a perhalic acid, perchloric acid, perbromic acid, periodic acid. These are some common oxo acids of halogen. Two most important common point is there. We have to discuss about the acidic nature of different oxo acid. Mark that. Discuss about acidic nature under the heading of note. Two important points. One is, in all oxo acid of chlorine, it undergoes sp3 hybridization. Second point, for same oxidation state, but for different halogen, that is, higher is the electronegativity, of halogen, higher is its acidic nature. Mark that. I repeat again. That is, for same oxidation state, different halogen, then higher is the electronegativity of halogen, higher is the acidic nature. For example, HOCl greater than HOBr greater than HOI. Mark that. In each case, same oxidation state, that is +1. But if the same oxidation state different halogen, higher is the electronegativity, higher is the acidic nature. So acidic nature gradually decreases as HOCl, HOBr, HOI. Next point is, here oxidation state same, halogen differ. Next is halogen same, oxidation state differ. Mark that. Third point is, for same halogen but with different oxidation state. Same halogen but with a different oxidation state. Then higher is the oxidation state. Higher is the oxidation state, higher is its acidic nature. Mark that. I repeat again. Previous point. Same oxidation state, different halogen. Now same oxidation, now same halogen, different oxidation state. Then higher is the oxidation state, higher is the acidic nature. That means, for example, HClO4 greater than HClO3 greater than HClO2 greater than HClO. Mark that. Here is +7, +5, +3, +1. Same halogen. It is acidic nature. Gradually decreases. Mark that. Same halogen, that is a chlorine, but different oxidation state. +1, +3, +5 and +7. Then the oxo acid having higher oxidation state is higher acidic nature. These are some important points relating to the oxo acid. Last we discuss about uses of hydrochloric acid. So many uses are there. That is, most important thing, used as a laboratory agent. It is used for the preparation of aqua regia. It is used in the industry for manufacture of dye. It is used for the preparation of that is poisonous gases, oxygen, tear gas. These are all about the uses of hydrogen fluoride. It is all about the chapter halogen family or group 17 elements.